This is Unit 9, Lesson 1, Introduction to Trigonometric Ratios. Trigonometric ratios are simply ways of relating the sides of a right triangle to its angles. And we're going to use these ratios to find missing angle measures and missing side lengths. And we're going to focus on 6 specific ratios. And these only work in right triangles. Later on in this unit, we'll look at some problems that will let us solve for something other than a right triangle, like an obtuse triangle or an acute triangle. Today and tomorrow, we're really going to focus on these 6 ratios. The first one is sine, and this says the sine of theta. This symbol just is a theta symbol. It is used throughout the unit to just indicate which angle we're writing the function or writing the ratio in relation to, because our ratios are all about the relationship of the legs and the hypotenuse of the right triangle to a specific angle in that triangle. So we'll always indicate which angle that is by using the theta symbol. So the sine of theta is the opposite leg over the hypotenuse. The cosine of theta is the adjacent leg over the hypotenuse. And the tangent of theta is the opposite leg over the adjacent leg. And these 3 ratios are going to allow us to find missing side lengths. Now, the inverse of all of those are actually called the inverse of sine, the inverse of cosine, and the inverse of tangent. Those inverse ratios will allow us to find the missing angle measures. So to find your theta angle, you would use the inverse of sine, and you would do the opposite over the hypotenuse. So sine to the negative 1 power times the opposite leg over the hypotenuse. You could also do the inverse of cosine, which is the adjacent leg over the hypotenuse. And you can do the inverse of tangent, which is the opposite leg over the adjacent leg. Notice the ratios themselves never actually change. Whether we're using sine of theta or the inverse of sine, cosine of theta, inverse of cosine, tangent of theta, or inverse of tangent, all depends on what we're looking for. Now, you also have to be able to know these ratios and set them up without having a reference sheet, without having a cheat sheet to look at. So, we have this nice little saying, some old hippie caught another hippie tripping on acid. It's a ridiculous sentence. Sounds ridiculous, is ridiculous. Makes Mr. Swallow shake his head every time we say it. But it helps us remember these ratios so that we can set them up correctly. So the first 3 words, some old hippie, the S is for sine, the O in old is for opposite, and the H in hippie is for hypotenuse. The sine is the opposite over the hypotenuse. The next 3 words, caught another hippie, C is for cosine, A is for adjacent, and H is for hypotenuse again. So cosine is adjacent over hypotenuse. And tripping on acid, T is for tangent, O is for opposite, and acid, or A, is for adjacent. And that would be the tangent is the opposite over the adjacent. So you're going to want to remember this little sentence and remember that these are the relationships that get set up to solve for missing side angles and measures, and angle measures. So the first thing we want to do is we want to just work on writing the trigonometric ratios. That's the biggest struggle for a lot of people, is writing the ratios. So we're going to write the sine ratio, so we're going to do the sine of theta, and we're also going to do the inverse of sine. We're going to do the cosine of theta, and we're going to do the inverse of cosine. We're going to do the tangent of theta, and we're going to do the inverse of tangent. So what you want to do, the easiest thing to do, is find your theta angle, and from your theta angle, identify all 3 sides of the triangle. Remember, the hypotenuse is always opposite the 90-degree angle. So here's my hypotenuse. And then the adjacent and the opposite are all about their relationship to this theta angle right here. So if theta is in this bottom corner right here, opposite my theta angle, go to the other side of the triangle, the opposite side of the triangle, this is my opposite side. Adjacent is the side of my triangle that is right next to, it's adjacent to my theta angle. So it's right next to it. It helps make my theta angle. You're going to want to do this because these things don't move around for setting up each ratio, but they do move around depending on where your theta angle is at. So the sine of theta, so sine is opposite Sine equals opposite over hypotenuse. So the sine of theta is the opposite, which is C, over the hypotenuse, which is A. No numbers yet, just letters. And then the inverse is going to be the same thing, only without a parentheses or without an equal sign, because we're looking for the angle measure there. We're going to take the inverse of sine and multiply it times that ratio. The cosine of theta, cosine is adjacent over hypotenuse. And so the cosine of theta, so as we go back to theta, we find the adjacent leg is B, and we put that over the hypotenuse. And our inverse does the same thing. I keep wanting to say equals, but the inverse does not equal anything. It's simply a set of parentheses right next to the shorthand for cosine, the inverse of cosine. So all we're doing here is we're setting these ratios up. That's all we want to do today, is set the ratio up. So tangent is tripping on acid. So tangent is opposite over adjacent. So the tangent of theta, go back to theta, opposite is the C leg, adjacent is the B leg. So the tangent of theta is C over B, and the inverse tangent of theta is also C over B. So if you can get the first one set up, if you can get the tangent set up, the inverse is just as easy because it's the exact same thing. So what we need to be able to do is identify the hypotenuse and the two legs of our triangle so that we can write all three of these ratios. So example 1 says write the sine, cosine, and tangent ratios and the inverse of each for the theta angle. So you're going to find your theta angle, and from theta you want to identify all of your parts. So leg A is right here, and leg A is opposite the 90-degree angle. So leg A is the hypotenuse, and I'm just going to abbreviate so that it fits in that little line right there. From my theta angle, B is over here on the other side of the triangle. So B is opposite the theta angle. And leg C is right next to it, so leg C is adjacent to the theta angle. Always identify where your opposite and your adjacent and your hypotenuse are before you start, because if you don't do that, you're going to be digging around trying to find what you need in the middle of trying to get all your work done. So the sine of theta, remember sine is opposite over hypotenuse. So the sine of theta in this problem, so my opposite leg is B, my adjacent leg, or my hypotenuse is A, so it's going to be B over A. And then the inverse of that is just going to be B over A, no equal sign. And use that power of the -1 right there so that you realize it's the inverse of sine. And then we want to do the cosine of theta, and cosine is adjacent over hypotenuse. So the cosine of theta, my adjacent leg was C, the hypotenuse is still A, and the inverse of cosine is going to be C over A. And then we do the tangent of theta, and tangent is opposite over adjacent. So the tangent of theta is going to be my opposite leg. My opposite leg was B over my adjacent leg, which was C. And so the inverse of tangent is going to be B over C. It's really simple. It's a matter of keeping your opposite and your adjacent and your hypotenuse straight, and which one of them goes with which one of these ratios. So let's look at example 2. Example 2 actually uses some numbers, and at this point we can actually start to check our work and make sure that we're actually setting our ratios up correctly. When you're just looking at numbers, the numbers are great, but I like to be able to actually check my work. If you look at example 3 in your notes, the example 3, or in the notes booklet, example 3 and the example 3 in your notes will have a description on how to set your calculator up so that it does this correctly. So we'll talk about that just a little bit more in a second. Let's go ahead and let's look at example 2. Example 2 says write the sine, cosine, and tangent ratios and the inverse of each for the theta angle. So let me get this whole picture in here. So we want to identify our hypotenuse, our opposite, and our adjacent legs. So the leg opposite theta has a measure of, so here's theta. On the other side of the triangle, theta, from theta, the opposite leg has a measure of 4. The adjacent angle, or the adjacent leg, has a measure, so here's theta. And who's right next to theta? 5 and 3 are right next to theta, but what you need to take into account is there's the 90-degree angle, so that makes 5 the hypotenuse. So the hypotenuse has a measure of 5, so that means the adjacent angle has a measure of 3. And I'm going to go ahead and I'm actually going to write in hypotenuse, adjacent, and opposite on here, just because it's a little easier to keep those straight than it is a bunch of numbers. So let's start with the sine of theta. So the sine of theta is going to be the opposite over the hypotenuse. And so the opposite over the hypotenuse, so the sine of theta, the opposite leg is 4, and the adjacent, or the hypotenuse of the triangle is 5. And I said we could check these, but we can't check them yet because we don't know the value of theta. We won't know the value of theta until the next question. But the inverse of sine is going to be the same thing. It's going to be 4 over 5. And then we're going to do the cosine of theta. From theta, we're going to do, in this case, we're going to do adjacent over hypotenuse. And so the cosine of theta, adjacent to theta is the 3, and the hypotenuse is still 5, not going to change. So the inverse of that is just going to be the inverse of cosine times 3/5. And then the tangent, the ratio for tangent says opposite over adjacent. So the tangent of theta in this problem, the opposite leg is 4, the adjacent leg is 3. So that means the inverse of tangent is 4 over 3. So let's keep setting these up. Let's set one more up, and then we're going to do it for all 3, and we're actually going to check our work in this problem. So we want to identify the legs from the given angle and the opposite leg. So the given angle isn't theta now. The given angle is 37 degrees. So we're going to do everything in the relationship to this 37 degree angle. From the given angle, the opposite leg measures, so we're standing here, the opposite side of the triangle measures 3. The adjacent leg, well, we still have 2 sides, and both of those touch that 37 degree angle. So before you decide which one's adjacent, go ahead and decide which one's the hypotenuse, because that's easier. The hypotenuse is always opposite the 90 degree angle. So if there's the 90 degree angle, the hypotenuse measures 5. So that means the adjacent measures 4. Let's go ahead and, just for the sake of our sanity, let's label these opposite, hypotenuse, and adjacent. So we're going to do the sine of 37 degrees. So now the sine, or the angle, has a measure degree. So we're going to say the sine of 37 degrees is equal to, and sine, if you will remember, sine is adjacent or opposite over hypotenuse. So opposite over hypotenuse. So the sine of 37 degrees equals opposite, which is 3, over the hypotenuse, which is 5. So that means the inverse is 3/5. Now here's where you can start checking these in your calculator. Because you now have an actual angle degree measure, you can check these in your calculator. Now, if you look in your notes, you'll see a description on how to make sure your calculator is in the right mode. But what I want to do first is go ahead and clear your calculator out. Go ahead and do the reset of all the RAM. So that you get back to this and it says RAM cleared. And when we want to make sure that our calculator is in the right mode, because it's literally a mode, there's 2 modes, there's a degree mode and a radian mode, we're going to hit the mode button. And if you look about 2-3 lines down, it says radian and degree. So we're going to arrow down to that, and we're going to arrow over so that degree is flashing, and we're going to press enter. That means our calculator is now in degree mode, and all we have to do is second quit, and everything we do from now on out is going to use the sine ratios. And if you'll go back, I will post a video that also will kind of explain to you what these ratios mean. It's kind of a long, involved explanation that we're not going to go into just yet. So we want to check and see if we've got the right ratio set up. So we're going to go and we're going to say the sine of 37 degrees, and we're going to hit enter. And we get this big long decimal. That's fine. Now let's say 3 divided by 5 and hit enter. These two decimals, they're not exactly the same, but they're very close to one another. And because these two things are very close to one another, we can say that we have the right ratio set up. And you can also, if you do the inverse, to do inverse, you do second, and then you hit the sine button again. And because if you look, the inverse of sine is right above the sine button. So we hit the inverse of sine, and we put that fraction in, 3 divided by 5. And we should get this angle measure, or almost this angle measure. Because we're dealing with some really specific numbers here, you're going to get some really long decimals. So if you look, if we do the inverse of sine with 3/5, we get 36.8. Well, if we round to the nearest whole number, that's 37 degrees. So these two are almost exactly the same. This can be rounded to the angle measure that I was given. So I have set up the correct ratio. So let's do the same thing for cosine. So we're going to do the cosine of 37 degrees. And remember, cosine is adjacent over hypotenuse. So we're going to do the cosine of 37 degrees is the adjacent leg, which is 4 over 5. And the inverse cosine is also going to be 4 over 5. And we can check our work. We can do the cosine of 37 degrees and 4 divided by 5. Very similar. The top one could be rounded to match the bottom one. And then we can do the inverse. We do second cosine to get the inverse of cosine, and 4 divided by 5. And we hit enter. We should get somewhere around 37 degrees, 36.86 again. So now let's do the tangent. The tangent of 37 degrees in this particular problem is going to be the opposite over the adjacent. So the tangent of 37 degrees is going to be the leg that's 3 over the leg that is adjacent, which is 4. So the inverse of tangent is going to be 3/4. And so we can go back to our calculator and we can go the tangent of 37 degrees should match 3/4. Well, we should know that 3 divided by 4 is 0.75. So those are almost exactly the same. And we can do the inverse of tangent and 3 divided by 4, and we should get somewhere around 37 degrees. There you go, that 36.86 again. So you can check your ratios if you have all of the information. Today you're going to have all that information. You can check your ratios all day long in this lesson to make sure that you're setting them up correctly. The second most difficult part of this unit is going to be determining which ratio to use. So you're going to have to take the time to identify what information you have and then set up the ratio that matches the information that you have. You don't just go, I'm going to use this ratio and then try to make the information match it. You have to look at the information that's in your triangle and make the information in your triangle go with the ratio, not make the ratio go with the triangle. Does that make sense? So we're going to look at this triangle right here, and we're going to identify what we have, and then we're going to pick the ratio that we need to set up. So we're given that the given angle is 32 degrees. From here, we've got two pieces of information. We've got this side that measures 5 and this side that measures 8. From 32 degrees, 5 is on the opposite side of the triangle. So this is my opposite leg, and it measures 5. And then this 8 that is right next to my 32 degrees is my adjacent leg, because remember, this is my hypotenuse. It's on the other side of the 90-degree angle. It's far away from the 90-degree angle. That makes this my adjacent leg. So my adjacent leg measures 8. So now you know you have an opposite leg and you have an adjacent leg. Well, opposite and adjacent are used in the tangent ratio. So we're going to set up a tangent ratio. So we're going to say the tangent of that 32 degrees equals the opposite leg, which is 5, over the adjacent leg, which is 8. And the inverse of that would just be 5 over 8. And you can check that in your calculator. Just punch in tangent of 32. See if it matches 5 divided by 8. Should be about the same. And then do the inverse tangent of 5 divided by 8. And you should find that the answer to that would be 32 degrees, or somewhere close to 32 degrees, maybe not exactly. So let's take a look at example 5 and see if we can determine which ratio we need in example 5. So in example 5, the 60-degree angle is given to us. And then let's identify the sides of our triangle. So from here, opposite would be over here. I don't know anything about that opposite leg, so I'm not going to be able to use it. Here's my 90-degree angle, so this is my hypotenuse. That means the leg left that's right next to my 60-degree angle is my adjacent leg. So the hypotenuse measures 6. The leg with a measure of 3 is adjacent to the given angle. So I have a hypotenuse and I have an adjacent angle. So you go back to the very beginning of the lesson and you go, okay, which one of my ratios uses hypotenuse and adjacent? Well, cosine uses opposite or uses adjacent over hypotenuse. So the cosine of theta is the adjacent leg over the hypotenuse. So we're going to use this ratio to set up this triangle. So instead of the cosine of theta, now we're going to say the cosine of 60 degrees is equal to the adjacent leg, which measures 3, over the hypotenuse that measures 6. And that means the inverse of cosine is just 3 over 6. And you can check that in your calculator. We're still in degree mode. I haven't changed anything. The cosine of 60 degrees is 0.5. 3 divided by 6 is 0.5. The inverse of 3 divided by 6 is, look at that, exactly 60 degrees. So we know we've set both of these up correctly. What you might want to do as you're doing your assignment is check the first one, and if the first one's good, then you know the second one's good. Because there's no reason for you to go changing things around from the first one to the second one. All right, so let's identify the information we have in example number 6. Example number 6 looks an awful lot like example number 5, so we've got to make sure that we identify all of our sides. So we know the 60-degree angle. We know that on the opposite side of the triangle measures 5, so there's my opposite leg. We know that this is on the opposite side of the triangle from the right angle, so that's my hypotenuse. That means this one right here next door that makes my 60-degree angle and my 90-degree angle has to be my adjacent leg. So the hypotenuse measures 6. The leg that measures 5 is opposite the given angle. So we have a hypotenuse and we have an opposite. And opposite and hypotenuse are used in sine. The sine of theta is the opposite leg over the hypotenuse. So now we're going to say the sine of 60 degrees is the opposite leg that measures 5 over the hypotenuse that measures 6. And the inverse of sine is also going to be 5 over 6. Make sure that you take the time to label your triangles so that you know where your adjacent and your opposite are. Make sure that you know that your hypotenuse is always opposite your 90-degree angle. If you don't have these things labeled correctly before you start, it doesn't matter how well you know these trig ratios, you're not going to be putting the right numbers in the right spots.